What happens to potential energy when its height is double? So I have case 1, the mass of an object, h is its height and g is the acceleration due to gravity. Then in the second case, the object is now taken higher. It's the same object, so mass is the same. The height is now 2h because it is double. We said the height is double. The g remains constant. So here potential energy 1 mgh and potential energy 2 mg. Now the h is 2h. I will just rearrange it, 2mgh. So you have 2, and if you notice this mgh is the same as potential energy 1. So here I'll do potential energy 1. So potential energy 2 is 2 times potential energy 1. So I can say the potential energy also doubles. A boy weighing 40 kgs, so mass 40 kgs, makes a height jump of 1.5 meter. So the height to which he jumps is 1.5 meter. What is its kinetic energy at the highest point? Now when the person is jumping at the highest point and he comes down, at this highest point the velocity keeps on decreasing, and here the velocity becomes 0. So at the highest point, the kinetic energy, formula, is half mv square. At highest point, v is 0 because it keeps decreasing, v equal to 0. So kinetic energy at highest point is half m into 0 square, which is 0. Next, they're saying what is its potential energy at the highest point. Now at the highest point, the mass we know is 40 kg. He has jumped through a height. This height is 1.5 meter. His height is 1.5 meter. G is 10 meter per second square. Here he possesses potential energy, formula mgh, 40, g 10 and h 1.5, and when you multiply this you get the answer 600 joule is the potential energy at the highest point. To what height should a box of mass 150 kg, so height we need to find, mass is 150 kg, be lifted so that the potential energy becomes 7,350. So potential energy is 7,350 joule. G is given as 9.8 meter per second square. We know formula for potential energy is mgh. So the potential energy is given 7,350. The mass is given 150, your g is given 9.8, and this is h. So we need to find the h. So it is 7,350 over 150 into 9.8. To work this, you get 7,350. To remove the decimal, we put 10, so this becomes just 98 over 150. So this is the height. On working, you get 5 meter. So the object has to be raised to 5 meters so that it will get a potential energy of 7,350. A body of mass 2 kg. So we have mass 2 kg is thrown up vertically upwards with the initial velocity of 20 meter per second. So your u is initial velocity 20 meter per second. What will be its potential energy at the end of 2 seconds? So time is 2 seconds. So we must know the distance, the height it has covered in 2 seconds. So when an object is thrown vertically upwards, here the u is given as 20 meter per second. The acceleration due to gravity will be taken negative because the velocity is decreasing. Of course, v is 0. So the first step is to find the height to which the object is moving. So height, or we call it distance, you can say height or you can call it s, whichever you want. So that is ut plus half at square. And usually for a body that is moving up, the distance is the height. We have ut plus the a, the acceleration due to gravity, is g, t square. So h equal to u we know is 20, t is 2, half. Now the g here is minus 10 because the body is moving upwards. That is retardation. So you got to write there is retardation. You got to mention why you've taken negative. T square is 2 square. So your h is 40 plus half into minus 10 into 4. So you cancel this out, you get h equal to 40 minus 20, your h equal to 20 meter. Now it's time to find the potential energy, and you know the formula for potential energy is mgh. M2, here we have g is will take 10. Now remember, energy is a scalar quantity, so there's no need of that g to be negative or positive. We just take it as 10, and the height is 20. So this is 400 joule will be the potential energy. A man is instructed to carry a package from a base camp at B to a summit A of a hill at a height of 1200 kilometers. So let me just write this. So here's the base. He's first at the base camp B, and then he's been asked to carry a package to the summit. Suppose this is a summit here right on the top, which is A, and they said the height, this height from A to B, this h, is 1200 meter. The man weighs 800 newtons. So the weight of the man, not mass, this is weight of the man, is 800 newton. And the package weighs 200. So weight of the package 200 newtons. The question, how much work does he do against gravity? Now you know the work done while moving from B to A, as he is moving from B to A, the work done will be always mgh. Now the total weight that is being carried from base camp B to summit A is that total weight is of the men plus package. Now men 800, package 200, so that is 1000 newtons. Now this is weight, so it is equal to mg. It is not mass, it is weight. So this mg is already given to us, and that is 1000. And the height we know here is 1200, so into 1200. So the work done, this is work, is 1200 with 5 zeros joule. Now for the second part of the sum is, what is the potential energy of package A if it is assumed that to be 0 at B? So potential energy formula mgh. Now we are calculating only of the package, not of the men. So the mg, m into g, which is directly given to us, 200 newtons is the weight. 200 newtons is m into g, is 200. N is moving through a height of 1200, so into 1200. So the potential energy of the package will be 240000 joules, as compared to taking B as a ground level, as zero potential. A body of mass 100 kgs is lifted by 10 meters. So the height to which it is lifted is 10 meter. Find the amount of work done. So work done in lifting an object is always mg is the force and the height is a distance. So here we have 100, we have g is given as 10, and this is height. So this is 1, 2, 3, 4 joule is a work done. Now this work, you can just mention this work is done against the weight of the object, or the gravitational pull of the object. Next is, what is the potential energy of the body? Now potential energy is always equal to the work done in lifting the body to that height. So but we'll calculate again. Potential energy also is mgh. So here you have m 100 into 10 into 10, which is 10,000 joules is the potential energy. A body weighing 50 kgs, so mass, a boy weighing 50 kg, this is the mass given, climbs up a vertical height of 100 meters, so h 100 meter. Calculate the amount of work done by him. So work done in lifting an object is force into displacement, and while lifting an object, the force is the weight, work is to be done against the weight, displacement is h. So here we have 50 into g, we've given 9.8 and 100, and that is 49000 joule work done. But if you want to put in scientific notation, remember the decimal has to go here. 1, 2, 3, 4 places, so 4.9 into 10 raised to 4 joule. And the second part of the sum says, how much of potential energy does he gain? Yeah, the work done is converted into potential energy, is converted or stored as potential energy. So potential energy is also 4.9 10 raised to 4 joule. Two bodies A and B of equal masses. So I have A with mass m, B with also mass m, are at a height of h at 2h. This height is h, this height is 2h. Find the ratio of their potential energy. So potential energy mgh here, potential energy 1, and here potential energy 2 mg. Now remember, h is 2h here, the height is 2h. Now we find the ratio. So to find the ratio, we do potential energy 1 over potential energy 2, that is mgh over mg2h. So this cuts out, oh no, so I have to cut out the h here. So you have 1 by 2. So the ratio of their potential energy is 1:2.